Okay, we're still doing confidence intervals. A lot of this is still the same, except now we're looking at proportions. Remember proportions before? They follow the binomial distribution, which can be approximated. You can approximate it by using the normal distribution. Okay, when can you do that? Well, remember N and P and Q. N is the sample size, P is the probability of success, and Q is the probability of failure. And all Q is 1 minus P. So P and 1 minus P add up to 1. The probability of success, if P was 0.20, then Q would have to be 1 minus 0.20, which would be 80. That's some of the stuff we did with binomial distributions. But you can use a normal distribution on binomial distributions if you take N times P and it's 5 or larger, and you take N times 1 minus P, which is Q, and it's also larger, 5 or larger. If it is, then you can use the normal distribution. So the confidence interval for the proportion, remember proportion is a fraction, okay? So to get your proportion, you're going to take however many successes you have, okay, and divide it by N, which is your sample size. So that would be a proportion, which you can change to a decimal. Then you're going to get so that's your proportion. Then you're going to get your standard error for your proportion by using this formula. Okay, once you get your standard error from your proportion, this is the, let's see, here's a sample, here's the standard error of the proportion, but let's look at this. Since the population proportion is unknown, it is estimated using this sample. This is the formula for the approximate standard error of the proportion. So look at your confidence intervals. Okay, it's very similar, except instead of having X bar, which is the sample mean, now we have the sample proportion. And we're still going to do plus and minus, and we're going to use Z again. Okay, and your Z value, your critical value there, you're going to multiply it times your standard error of your proportion. Remember what this was called? Your margin of error. So a lot of this is the same. So here's the formula for the margin of error. That formula will give you, when you multiply these together, that gives you the width of your confidence interval, what you need to add and subtract from your sample proportion. And remember, for T and for Z, for the normal distribution and for the T distribution, we could calculate the margin of error in Excel. So that does save time when you're able to do that. Here's just an example, which we're going to work an example together. And that's pretty much it. We're doing very similar things here, except now we're looking at proportions.